Okay, this recording is about molality. Do not get molality and molarity mixed up. There's a difference between them, a difference in their definitions. So you should have your notes ready to go because you're going to write down some sample problems while you're watching this. You should have your calculators. You should have your periodic tables for any type of converting that we would need to do. All right, so what's the difference between molarity and molality? Molarity, by its definition, is how many moles you have of your solute per liter of solution. But molality is, by definition, how many moles of solute, so that's the same between the two of them, but it's divided by how many kilograms of the solvent, only the solvent that you have in your problem. With the other one, with molarity, it's how many liters of solution, which everything's mixed together. Another difference between them is how you represent their units. Molarity is capital letter M for a molar, and molality is a lowercase m, okay, which stands for a molal. You can, like before, you can either use the lowercase m or you can actually write down moles per kilogram as a unit. That's up to you. You choose which one you would like to use. Um, and then the equation is right here. So let's just practice a couple problems and see how this will work. So it says, what is the molality of a solution containing 10 grams of sodium sulfate dissolved in 1,000 grams of water? So you have your solute and you have your solvent. Now, according to the equation, to find molality, it's moles of the solute over kilograms of the solvent, which neither one of these are in the appropriate units. So I have 10 grams of my solute. It needs to be in moles. So we have to do some converting here. So we have 10 grams of Na2SO4 times 1 mole over the gram formula mass. So we get your calculators, your periodic tables. Sodium is 23, and there are 2 of them. Sulfur's 32.1. And oxygens are 16 apiece, so you have 4 of them. So altogether, this adds up to 142.1 grams. So when we do our math, 10 divided by 142.1 is 0.0704 moles. Started with 3 sig figs, so you have to end up with 3 sig figs. So we have the moles. We have 1,000 grams. We have to change our grams to kilograms. So you need to move your decimal point 3 places to the left. So when we do that, when we move it 3 places, 1, 2, 3, we end up with 1 kilogram of water. So according to my equation, I take my moles, which I just determined was 0.0704, divided by my kilograms of my solvent, which when we move the decimal point is 1. All those zeros are significant, so you got to keep them significant. Divide the 2 of them. It's divided by 1, so we end up with 0.0704 molal solution. Now remember, you can do this also as a unit, moles per kilogram. So whichever one you're more appropriate or feel more appropriate with, because these do not cancel out. Moles divided by a kilogram don't cancel out. They'll turn into a molal, or you can just keep them moles per kilogram. So make sure you know that for the unit, just like with the molarity equation. Different unit though. This one, what is the molality of a solution containing 30 grams of naphthalene, which are mothballs, dissolved in 500 grams of toluene? So this is getting dissolved. So this is your solute. This is your solvent, not water this time. I think it's the only problem we've done where it hasn't been water, which is okay. Now, according to the equation, remember, it is moles of the solute divided by kilograms of the solvent. We don't have either of those units, so we have to convert just like we did on the last problem. So I have 30.0 grams of C10H8, which is the naphthalene. We're going to change that to moles. So carbon is 12 plus the hydrogen, so we're talking 128 for the gram formula mass. So 30 divided by 128 is 0.234 moles of the naphthalene, the mothballs. All right, and then we need to change our grams to kilograms. We need to move it 1, 2, 3 places to the right to change our grams to kilograms. So now we can go ahead and plug this in. So I have my moles divided by my kilograms, which is 0.5000. Keep all those numbers, they're significant. We're going to divide them. So 0.234 divided by 0.5000, and you get 0.468 molals, or if you like, moles per kilogram. So it's up to you which one of those units you're more comfortable with, because they don't cancel out, so it's easy to say what that unit's going to be.